Scientists caught sperm defying one of the laws of physics. With their whip-like tails, human sperm propel themselves through viscous fluid, seemingly in defiance of Newton's third law of motion, according to a recent study that characterizes the motion of these sex cells and single-celled algae. Kenta Ishimoto, a mathematical scientist at Kyoto University, and colleagues investigated these non-reciprocal interactions in sperm and other microscopic biological swimmers to find out how they slither through substances that should, in theory, resist their movement. When Newton conceived his now famed laws of motion in 1686, he sought to explain the relationship between a physical object and the forces acting upon it, with a few neat principles that it turns out don't necessarily apply to microscopic cells wriggling through sticky fluids. Newton's third law can be summed up as for every action there is an equal and opposite reaction. It signifies a particular symmetry in nature where opposing forces act against each other. In the simplest example, two equal-sized marbles colliding as they roll along the ground will transfer their force and rebound based on this law. However, nature is chaotic, and not all physical systems are bound by these symmetries. So-called non-reciprocal interactions show up in unruly systems made of flocking birds, particles in fluids, and swimming sperm. These motile agents move in ways that display asymmetric interactions with the animals behind them or the fluids that surround them, forming a loophole for equal and opposite forces to skirt Newton's third law. Because birds themselves generate their own energy, which gets added to the system with each flap of their wings or whip of their tails, the system is thrust far from equilibrium and the same rules don't apply. In their study published October 2023, Ishimoto and colleagues analyzed experimental data on human sperm and also modeled the motion of green algae, Chlamydomonas. Both swim using their thin, blendy flagella that protrude from the cell body and change shape or deform to drive the cells forward. Highly viscous fluids would typically dissipate a flagellum's energy, preventing a sperm or single-cell algae from moving much at all, and yet somehow the elastic flagella can propel the cells along without provoking a response from their surroundings. The researchers found that sperm tails and algae flagella, have an odd elasticity, which allows these flexible appendages to whip about without losing much energy to the surrounding fluid. But this property of odd elasticity did not fully explain the propulsion from the flagella's wave-like motion. So from their modeling studies, the researchers also derived a new term, an odd elastic modulus, to describe the internal mechanisms of flagella. From solvable, simple models to biological flagellar waveforms for Chlamydomonas and sperm cells, we studied the odd bending modulus to decipher the non-local, non-reciprocal inner interactions within the material, the researchers concluded, and the findings could help in the design of small self-assembled robots that mimic living materials, while the modeling methods could use a better understanding to underlying principles of collective behavior, the team said. The study was published in PRX Life, and this is on Science Alert by Claire Watson. Please leave your comments and thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.